This comes out of section 4.2, maximum minimum value. So to start this one, we have a strange looking function drawn here. I've got some points labeled since we're not using graph paper, and we're asked something that we haven't seen before, which is absolute maximum, absolute minimum. And these are things that we've actually, in regular everyday English, we can probably understand what that means. The absolute maximum value of this graph is just the highest it goes. So the highest this graph goes here is at this top point here, it's at 9. So the maximum value is 9. It happens at the point 6, 9, depending on how it's asked. If you're asked for the point or if you're asked for the value of the function. The absolute minimum is just exactly what it sounds like. The lowest this function is going to go anywhere in this domain. And so the absolute min value of this function is -3, or it happens at the point -5, -3. It gives a bit more information. So those are, your extreme values, your absolute max, your absolute min, and they are what they sound like. You could only have one absolute maximum, absolute minimum, and in some cases you won't have any. If the graph just keeps going up, you'll never have a max, and if it keeps going down, you'll never have a min. Now, you also can have something called a local max or a local min. Local. And local min. So local maximum just means that that point is higher than all the points around it. So, for example, the point -1, 5. It's not the highest point anywhere on the graph, but it is higher than every value around it. The graph falls in both directions as you leave that point, so it's the local maximum. The point 69 is a local max, but since we've already listed it as an absolute max, we don't really need to list it here. Local minimum, we have a few actually. Now we've already listed the absolute min, so we won't say it again, but we also have the point 2, 2, which is lower than all the points around it, and we also have the point 9, 1, which is lower than all values of the function around it. So you'll be asked in this section to find absolute or local min-max values for functions. So let's do a couple of real quick examples with some functions we're familiar with. So y equals x squared is a graph we've seen many times, just a parabola facing up. It has no maximum value at all, not local nor absolute, but it does have one minimum value. So it has an absolute min in this case, because at 0, 0 is the lowest this graph ever goes anywhere in its domain. Now, y equals x cubed is interesting because it looks like something's going on at the origin. There's a little wiggle in the graph there, but it's not the highest, nor is it the lowest point on the graph, and it's not even higher or lower than the points around it, because if you go to the right, you'll go up. If you go to the left, you go down. So it has no max or min values, not local or absolute, so no absolute or local max or min, whereas y equals x squared had an absolute min with no max, because the graph continued infinitely upward. So there's your introduction to absolute and local max and min.